So today we're talking about horizontal, vertical asymptotes, and this is the intro into rational functions. All right, so rational functions has the word rational in it. If the ACT said the following answer must be rational, do you know what that means? Give me the 3-4 word definition of a rational number. A rational number. Some of you just lost a point on your ACT. So I would write this down. Rational means, this is the whole unit's called rationals. Rational numbers can be written as a fraction. So there's things that can't be written as a fraction? Yeah, like pi. Everybody thinks 22/7 is pi, but it's not. That's a good approximation of pi because it comes out to 3.14, but then after that it gets off. It's not perfect anymore. All right, so there isn't a way to write pi as a fraction. That's the whole point. Pi is not what then? Rational. Okay. So rational numbers can be written as a fraction. So is this written as a fraction? Yes, it is. And you don't know what it looks like. I don't even know what it looks like. I kind of know what it looks like. But if I told you this one, 1 over x plus 3. Oh, can you get your tag? It's over there. I would say that one is something you should know. Because it's 1 over x, but it's been moved. Refresh your memory. What's 1 over x look like? Can you do it in your head? Like, you know where the little swoops are? It's like this. Does that ring a bell? It's one of the top 10 that you're supposed to know. And then I move it 3 to the, what does that mean? It's on the inside. 3 to the left. Good. And if I had put a plus 3 out here, that would also moved it up 3. Okay, so this is 3 to the left. This is up 3. All right. So what's this, though? Well, you're going to learn how to graph things like that you don't know. You don't have this one. It's not memorized. But you can figure it out. And thank you very much. It'll have horizontal and it'll have vertical asymptotes. All right, so let's get started on our slides. So this is official definition of a rational function. It's a ratio of two different polynomials, and that means basically a fraction where there's a polynomial on the top and a polynomial on the bottom. And remember that polynomials can be simple as a number. You know, like a polynomial can just be y equals 5. That's a polynomial still. All right. Okay, so here is a polynomial, and do you remember how to find domain? Hint, it's related to one of the asymptote types. Think close now. If this is -1, I know you know that matters, but does the top being equal to 0 cause an asymptote or cause the function to crash? No. The top being equal to 0 tells you something, though. Does anybody remember what it is? If the bottom's 0, you just crashed your function, and that means x cannot be -1, and that's part of the domain. The domain is all the things you can safely feed the function. Okay, so this tells me that I can feed the function everything except -1. All right, but what the heck is the 1/2? 1/2 makes the top 0. So it's the... better take notes. The thing that makes the top 0 is going to make the f of x be 0. What makes the f of x 0 is like what makes y 0. What makes y 0?
X equals 1/2.
Yes, x equals 1/2 makes y 0, but you're missing the point. There's a name for the thing that makes y 0. Yes? The x-intercept. Okay, so the 1/2 here is the x-intercept. It is not one of the asymptotes. But -1, you know how we say it can't be -1? So what we're saying is, at -1 here, nothing can be there. So we put a dotted line there. So there is a vertical asymptote right there. It's the same thing that would crash your function. Whatever makes the denominator 0, that's a vertical asymptote. So if you're taking notes, VA makes denom 0. It's anything that would make the denominator 0. Okay, so that's how you get vertical asymptotes. So in this little section here where they're like, find the domain of this. Well, of course, you're going to get into like weirder and weirder situations. Can you make a denominator 0 here? Yeah. Just because you can't make the whole thing 0 doesn't mean you can't make that 0. So that thing being 0 would be, again, x cannot be -1. So that's the domain there. How about the domain here? Is there more than one thing that would crash this function? Yes. X equals 1 is one of them. What's the other one? What can x also not be? Sam? Yep. Why? Because -1 acts exactly the same as 1 here. And if you had followed my advice, which is if you can factor it, you should, you would have immediately changed this into x plus 1 and x minus 1, because then you'd see it. It would be obvious. There's two things that can make the bottom 0. So there's two things that are vertical asymptotes. All right, so if I was going to actually graph this thing, can you imagine how awful it'd be to try to graph all of that? But I can tell you this. At x equals 1 and x equals -1, there's nothing. So I can go, here's -1, and here's 1, there's nothing. And then the graph has to, because of how asymptotes work, the graph has to do something where it gets closer and closer to those asymptotes. So like, let's say it's on the inside. I'm going to totally make up something. It could look something like that. It could look something like that. And it could look something like that. But your graph, notice how it always ends up getting closer and closer to the asymptotes. Now, am I saying that this one for sure looks like this? No, I'm saying it has two asymptotes. And it does something in between the asymptotes. Okay? Because how come it has to do something between the asymptotes? Because the only things it can't be is this and this. That's because 1 and -1 are the two things that would crash my function. Everything else has to have a value. Now, what if I told you could figure out any ugly, terrible graph? If you took enough time, it's your best friend in graphing. Say it louder. The XY chart. Yes. So you could pick some numbers and you could find a bunch of dots. If you get enough dots, you can just connect your dots and it'll probably get closer and closer to the asymptotes. There you go. That's this unit in a nutshell, this whole unit. If you can find points like this by sticking in a number you want, well, would I stick in 1? No, because it would crash the function. I might as well write 1 and say asymptote. And then -1 also asymptote. And then I could stick in other numbers like, well, let's stick in 0 and see what happens. Well, and if you stick in 0, I'd put it in here, and here, and here, and here, and we could get the answer. It would probably be pretty quick. It's -1 over -1, which is 1, minus -2 over -1, which is 2. So then it would be 1 minus 2, which would be -1. 0, -1 is on my graph. So I guess I was wrong. I guessed it would be 0, 0. It wasn't. It was 0, -1. And then you'd find a bunch more points. And eventually you'd start realizing, oh, it's got to get closer and closer to the asymptotes. Maybe it does this, though. Maybe it does like this. It's possible it could go like that and get closer and closer to the asymptotes. All right. So let's get to this page. Holes versus asymptotes. Would you please factor this top one? Because if you can factor it, you should. In higher algebra, you investigated these. You saw that there was holes when something happened. Did you get x plus 1 and x plus 6? Uh-oh, something went wrong. That didn't factor. I thought it was going to factor. Didn't factor. Oh, wait. Some other way to factor it. Who figured it out? Raise your hand if you did. Anjali. 3 and 2. All right, awesome. And let's go with Ava. Do you have the bottom one yet? Okay, x and x. And how about this? Marcus, talk me through what's the next thing after I put x and x. I do the signs next. Is that gonna be plus and plus or minus minus, or what is it? Plus and plus. Okay. And then it has to make 15. Can you do it?
3 and 5.
3 and 5, and then we'll double check that. Outside inside makes 8x. Looks like it worked to me. Now, why did they make it so that something would cancel here? Because that makes a hole in the graph. That is different than an asymptote in the graph. So, a second ago, I just told you that what makes the bottom 0 are asymptotes. But that was too simplistic. They're usually asymptotes. See, what makes the bottom here, -5 equals 0, that is a vertical asymptote. But this gives me a hole at -3. So, as usual, life starts out really simple. There's black and white, there's right and there's wrong, and then there's kind of gray. Where like, well, maybe speeding's okay if you're trying to save your friend who's bleeding in the seat next to you, and you're getting to the hospital, and like there's okay, so there's simple. Everything on the bottom is an asymptote. Well, usually it is, but in these rare freak circumstances where there's happens to be the same thing on the top and the bottom, then it isn't an asymptote. Then at -3, you have a hole in the graph. And to clarify, when you're doing a hole in a graph, it's like this, and all of a sudden at -3 here, it just won't exist, and then it'll keep going. The graph will just resume as if nothing happened. There'll just be an empty spot there. Whereas if there's an asymptote, let's say there was an asymptote at regular 3. If there's an asymptote, it has to get closer and closer and never touch that. Okay. So, don't forget about holes in the graph. And that makes a hole at -3. All right. Now find the vertical asymptotes and or holes in the following graphs. I've talked enough now that you should be able to be good at this. You should be able to figure out holes even when they're kind of complicated. Let's just talk about number 1 for a second, because people are going to freak out because they're like, how the heck do you make this equal 0? Well, just set it equal to 0 and solve it and figure out what makes it 0. Yeah, it's not a nice number, but you can figure it out. Did you figure out that that was square root of 3 and negative square root of 3? Don't forget, this is absolute value of x, because the square root of a variable gives you the absolute value, and then that is two things. X equals square root of 3 and x equals negative square root of 3. There are two, what are these things again? They make the bottom 0, but they're not holes, so they're what kind of asymptotes? Vertical. These are vertical asymptotes. I would appreciate it if you would call them VAs. Not for Veterans Administration, but for vertical asymptotes. So I have to tell you how to find horizontal asymptotes in a minute, and you have to be good at noticing when there's a hole every now and then. That's kind of what's left in the lesson. Would you please try this one and tell me its vertical asymptotes and if it has any holes? I'll pause for a second while you give that a shot. If you're already done with number 2, try a different one. Okay, you need to be really good at factoring by now. X plus 3, x minus 3. It's one of the reasons we keep pounding on that at the beginning with the top 20. Is because if you can't factor by now, you're kind of toast. So if you can't, some of you are just going to finally get good at factoring now. If I have a negative here, that means I need a plus and a minus. And then I'm thinking one of them's probably 3, because look, there's 3's on the bottom, and they're probably going to want one to cancel. So you can be smart like that and go, there's probably a 3 as one of them. And then if I use a 3 and a 2 like this, I would check it and go outside, inside, and that makes positive 1x. Dang, I needed it to be negative. Then whenever that happens, don't switch the numbers, switch the signs, because that technique will serve you well when you're doing the more complicated factoring. If you ever get the opposite of what you want, switch the signs, because, opposite of what you want, opposite signs. All right. And on a more complicated question, I could show you that that really is the better way to do it. Okay, notice that and that are the ones that will cancel off and make a hole. At x equals 3, there's a hole. So in the graph, wherever x was 3, like let's say the graph was running along like this, wherever x hit 3, then you'd be like, oh, doesn't exist there, and then the graph would just keep going. Okay. And then, was there a horizontal asymptote? Yes. Sorry, vertical asymptote. I take this out of the equation, I see what's left. Oh, that, at negative 3, there's a horizontal asymptote. So then I erase anything that I had there, and there's a dotted line through that. Question?
You said horizontal.
That is a vertical asymptote. You are correct. I think I corrected it already, but I could be wrong. I definitely get those two words confused sometimes. And let's talk about horizontal asymptotes right now. Does this one have a horizontal asymptote? All right. Does anybody know how to do this? You were taught this in higher algebra. I teach it with something that I describe as bigger on the bottom, bigger on the top, or same on both. Does anybody remember learning that in higher algebra? All right. Then, if it is humanly possible that they didn't teach it to you, but we're teaching it to you now. So, and some of you could tell me later, oh, I remember that now, if that's the case. Maybe. I'd love to know whether you really did learn it after I've taught you, if this rings a bell or not. Okay, so would you guys agree that this one has the same degree on the top and on the bottom? Then, obviously, it's same on both. And I'm going to call that an SOB. Same on both. Well, would you agree that it could have been a bigger degree on the top, or it could have been a bigger degree on the bottom if I had to change that degree, right? So the problem could either be bigger on the top, or it's bigger on the bottom, or it's same on both. Those are the three cases. It's either going to be bigger on the top, bigger on the bottom, or same on both. This is about its degree now, not how big its constant is or how many terms it's got. It's degree. Okay, so let's just make sure you really get that. If I gave you this one, is that bigger on the bottom, bigger on the top, or same on both? That's the bigger on top, okay. What if I put a 12 down here now? Clearly now it's bigger on the bottom, okay? Or if I keep them the same and I make this, just put a 12th power here, and that'll make them the same on both, won't it? Because even though it's not in the front, that is the biggest one, and that is its degree, so then I could make it same on both. Okay, so those are the three different cases. Either it's going to be bigger on top, bigger on the bottom, or same on both. All right, here's the rules then that you need to follow, and take notes. This isn't written nicely for you anywhere. It's not as nice as I'm going to write it. If it's bigger on the top, this is for horizontal asymptotes, maybe you want to label that, for your HAs, your horizontal asymptotes. Marcus, I feel like I need you with me right now. Okay, bigger on the top is the kind where there's a bigger degree on the top and there will be no asymptotes. So there's no bots. That makes me think of my son, who's excited about someday having one of those Tesla bots in his home as a like personal robot that he can be like, here, manufacture me a whole bunch of like surfboards because I'm going to sell them online. And the robot is in the basement like making surfboards. And if he's like wanting breakfast, he can be like, robot, make me 3 eggs. And he's excited about that. But his wife is like, nope, no bots. We're not having a bot in my house. That's too freaky. I don't want it. Too scary. What happens if somebody hacks it and the robot turns into a killing machine? And so anyway. So his wife is a no-bot person. He's a bot enthusiast. She's a no-bot. They'll eventually figure it out. My guess is that he won't get one of the first robots. It'll have to be like after it's been proven safe and whatever. Okay, so moral of the story, you get no asymptotes here, no HAs, if there is bigger on the top. That is the simplest thing of all, of course, is if it's bigger on top, you get to say, None. There are no horizontal asymptotes. Okay, how about bigger on the bottom? Well, that's a Bob. And I'm going to tell you this way to try to remember this, okay? Bob is a big 0. And it's kind of a way you could... Back in the old days, they actually... Yeah, he's a 0, meaning that he was like kind of a nerd or was not appreciated by most people. So Bob is a 0 because y equals 0 is your answer for a Bob. Unless we get really tricky, in which case there's something on the outside of the fraction. These are all fraction functions. If there's something on the outside, then he's an outsider. But 0 happens to also work as the beginning of outsider. And you guys are in honors, so you have to be able to handle weird situations. So Bob is really an outsider. What I mean by that is this. Here is one where it is a bigger on the bottom. Would you agree that this has a bigger degree on the bottom than it does on the top? Would you agree that it has a horizontal asymptote? We all know what that looks like. It looks like this. And it's got a horizontal asymptote, doesn't it? Okay. And what if I put a +3 here? Wouldn't that move everything, including the asymptote, up to 3? So Bob's an outsider. It takes whatever's on the outside of the fraction, and that becomes your asymptote, your horizontal asymptote. And in the case where you have a variable here, that becomes the slant asymptote. This may be going over some people's heads, but this is where instead of having a horizontal asymptote at 3, where this whole thing would have just moved up 3, you know, and everything's pretty normal except that the asymptote just moved up 3 spots. It has a horizontal asymptote where it gets tilted at an angle where the slope of that angle is 3. So you can have slant asymptotes. I had one on the very first slide, an example of a slant asymptote. That is kind of a side note. We, as far as I recall, I'm pretty sure we aren't even going to test you on slant asymptotes. Okay, but a lot of smart kids want to know how they happen. It's when you have a fraction where it's bigger on the bottom, and then it becomes an outsider, and what's outside the fraction is something with a variable. Then y equals 3x is the horizontal asymptote, and it's a slanted asymptote. So it kind of look like this. You'd have this line that goes like this. And then you'd still have a vertical asymptote at 0. And those are your asymptotes. Yes, go ahead.
Shouldn't that be a vertical asymptote at 0 instead of a horizontal one?
This horizontal asymptote, horizontal asymptotes are the, oh, you're right. It's not this way. I was prepared to explain how you were wrong, but you were right. It's this way. Thank you. Okay, and so then your graph ends up being inside of these asymptotes. I don't know why I'm spending this much time, but this hour, I have a lot of super bright kids who are like some of the best in their grade at math. So I think it's worth explaining for you guys how to do a slant asymptote. It's whatever's on the outside of a bigger on the bottom when there's a variable there. Okay, but for everybody else, all you'd have to know is that the asymptote has moved up 3. So it wasn't at y equals 0 anymore because normally if you just have y equals x, there's nothing out there. So you could argue that this is a bigger on the bottom and there's nothing out here. So it's y equals 0. It's still an outsider. It's whatever's on the outside. And there's nothing out there. So y equals 0 is the asymptote. Yes?
If y equals 0 is the asymptote, that would be the horizontal asymptote, right?
These are horizontal asymptotes. Yes, this whole category is horizontal asymptotes. Yep. I did throw in a vertical asymptote on the last one to just show you the combination of the two. This was a vertical asymptote here, and this was the horizontal asymptote, just going kind of weirdly, not normal horizontal. All right, so see if I have thoroughly confused you here. Let's figure out what the horizontal and vertical asymptotes are and if there's any holes. All right, Let's start with the category of horizontal because that's where we just left off. Is this bigger on the bottom, bigger on top, or same on both? It's the same on both, and that's the one case that I haven't told you yet. Does anybody want to make a prediction of what the asymptote is? Because you might remember this. It's not the kind where it's on the outside. It's not the kind where there is no asymptotes. That's the no bots thing. Remember, bigger on the top, and there's none of those. And it's not the bigger on the bottom kind where it's y equals 0, which is on the outside. It's y equals 1 over 1. Okay, so let's talk through why that would be. So on this graph, would you agree that it has a 1 as the lead coefficient? Okay, then do you also agree that this is same on both? Same degree on both. The rule for SOBs is that they are going to make you sob because they're the hardest kind. They're not just, there is no asymptotes. It's not just whatever's on the outside. It's a ratio of the lead coefficients. So in this case, that's a 1 and a 1. So it's y equals 1 over 1, which of course would simplify to y equals 1. So is there a horizontal asymptote? Yes, at y equals 1. Because there was a 1 here and a 1 here, and you go y equals 1 over 1. All right, before we finish this problem, I want to go just off to the side for a second and give you one of each case. Would you agree that this one is bigger on the bottom? So its horizontal asymptotes would be, what's a bob again? No, wait, no, it's bigger on the bottom. What's a bob again? Bob is a big 0. Or you could say Bob is an outsider. What's outside the fraction? Nothing. So y equals 0. Raise your hand if you knew it was y equals 0. Okay, good. Then that's the case for bigger on the bottom. What's the other next case? I usually go bigger on the top next. That's like x squared over, plus 7 over x. That's bigger on the top. What's the rule for bots? No bots. There are no asymptotes. None of the horizontal asymptotes. Is there a vertical asymptote? Just side note, is there a vertical asymptote for this one? Yep, it's at 0. So this one I have a vertical asymptote at 0, but we're not doing verticals right this second. We're just trying to make you a nice clean list of what happens if it's bigger on the bottom, bigger on the top, or the last one is same on both. 3x to the third plus 7 over 7x to the third. Let's say I had that. Well, that's got a horizontal asymptote. And this kind is the sob, which will make you sob because they're harder than all the others. And you got to remember a little formula, which is y equals a ratio of the lead coefficients, which is, in this case, y equals 3/7. Raise your hand if you already knew it was 3/7. Okay, good. There's your 3 ways to find horizontals. So, verticals make the bottom 0. What else makes the bottom 0? Sometimes. Rare, but sometimes. Makes the bottom 0. Give you an example. -3 makes the bottom 0 this time. Why isn't it an asymptote? Because it's a hole. Okay, this would have a hole, not a vertical asymptote. But wait, you were just talking about same on both. That's for the horizontals. What's the deal for same on boths again? SOBs. So what's the horizontal?
Ratio.
So SOB is a ratio of the lead coefficients, so y equals 1. Okay, so back to this big scary problem right here. I'm already breaking one of my rules, though. As soon as I saw this problem, I thought it, but I didn't do it. What do you think I'm talking about? Okay, if you can factor it, you should. Everybody factor that. Why is it especially important to factor? Because it catches the holes. Otherwise, you'd think that you add a vertical asymptote, but it actually turned out to be a hole. Adam, did you get factored already?
Yeah.
What'd you get?
I had, on the top I had x minus 3 times x plus 2.
I can verify you're right. And then on the bottom?
X plus 2 squared.
Ooh, fancy pants. You are correct. And that makes something special. There's a what at what? Yep. Hole at -2. Okay. And then this one is not making a hole. That's making a what? Vertical asymptote. At x equals -2. And then last but not least is this horizontal asymptote. Is it a bob, sob, or a bot? Is it bigger on the bottom, bigger on the top, or same on both? Same on both because those are the same. So then it's a ratio of the lead coefficients. So it's y equals 1. And that's the horizontal asymptote. There. Now the only thing other than that that you have to know is how to make a few other points. And what is your little point generator that works on every single graph? XY chart. You can always find a few points with an XY chart. Now I personally would cancel this off first because it'll make sure that it's so much easier to work with. Like now it's just this. See what I mean? Now I can make a few points for my XY chart way easier because it's just x minus 3 over x plus 2. So then if I want to put in like 3, I get 0. Ooh, that seems important. 3, 0. That's got the y is 0, so it must be the x-intercept. The x-intercept is where y equals 0. So many of these things come together on this lesson. It's one of the reasons I like it. It makes you review a ton of math. You know, the y-intercept is where x equals 0. The x-intercept is where y equals 0. Making XY charts. Factoring. All of them come into play. All right, so if I actually had to graph this thing now, it says the answer is this. Does that make sense to you then? Does it have a vertical asymptote at -2? Does it look like it has a vertical asymptote at -2? Look, yeah, it does look like it has a vertical asymptote at -2. Does it look like it has a horizontal asymptote at y equals 1? It does look like it has a horizontal asymptote at y equals 1. Does it look like it has a hole at -2? Oh, wait a minute. Wait a minute. I said there's going to be a hole at -2, and I said it's going to have a vertical at -2. Do you get it can't be both? Well, I can see the picture. Now that I see the picture, in the battle between the hole and the asymptote, which one won? Asymptote. So if, like this one, you have both a hole and an asymptote is more powerful than the hole. Asymptotes win. Okay. Now, if I was going to describe the end behaviors, I actually wouldn't have needed to do all of this. Would you agree that I could describe this with a limit? The limit of the function. As x approaches, well, if I go way to the right, I like my new way of doing this. This is headed towards what? If I extend it forever, would you agree x would be infinity? If I went forever, wouldn't that x value become infinity? Yeah. Would it rise forever, though? No, it would rise till it theoretically hit the asymptote, because it's going to get infinitely close to the asymptote, so we always say approaches. It approaches 1. So now I can write my limit for that. x approaches infinity, the limit of the function would approach 1. And you just take this number, and it's always the x, and then you take this imaginary thing it's headed towards, and it's the y. Okay? All right. Cool. You now know everything. So let's get to the homework. I think all of these are good. I really do. But do you really need to do that many? Nah. So let's skip this first one. I think doing this one would be good. Is this one a bigger on the bottom, bigger on the top, or same on both? Bigger on the bottom. Is there anything outside of the fraction? So you could say it's plus 0. So then Bob's an outsider. So it's y equals 0. So I know my horizontals from Bob. So I will sometimes just say, ask Bob what the horizontals are. And then you'll be like, Bob? Oh yeah, Bob, Sob, Bot. Those are the 3 things it can be. And sometimes they're Bobs, sometimes they're Sobs, sometimes they're Bots. All right. And the domain of this, the domain really needs us to factor this, because then we can see what the things are that'll kill my function. And if you can factor it, you should. And then I can see there's 2 things. And as long as there isn't a hole, then they're both verticals. This gives me a vertical, and this gives me a vertical. And Bob gives me the horizontals. This one is a Bob. And so therefore, you don't have to actually write Bob in your test. You just have to write the right equation, which is y equals 0. Always remember that horizontals and verticals, you can't just say 0, because I can't tell if you know which direction that goes. It's y equals 0 for a horizontal. And the verticals are always x equals things. And in fact, that's such a big deal that I'm going to introduce a dumb little word. Zertical and horizontal. It'll help when you're on the test and you're like, oh, this is a vertical, but I can't remember if that's x equals or y equals thing. Because it's easy to confuse. It's like a 50-50 chance. And if you guess wrong, you just screwed up your whole graph. The x equals things are vertical asymptotes. And the y equals things are horizontal asymptotes. So vertical and horizontal. You're welcome. Okay. And I think you should do 5. That would be good for you. These 2. Because that's mostly what we needed you to learn for today. All of those things. Domains, verticals, horizontals, holes. The slant asymptote, if it exists, I guess they even threw that in there, but I don't think we test on it. But the only way there would be a slant asymptote, in case you remember this, is if it's a Bob, and then you're on the outside, but there's actually something outside. So if your equation was like this, you'd go, oh, it's a Bob, bigger on the bottom. And then you'd go, so therefore it's an outsider, but there's something on the outside. Y equals 3x would be the horizontal. If your problem was this, then your horizontal, also known as horizontal asymptote, would have been at 3x, which is a slant asymptote because it's got a variable in it. This one doesn't have one. And then, what else? Well, they're all basically the same. They just get, this one's a weird one and yet weird good, because you got to think about, what if you can't make the bottom 0? Well, then you just can't make the bottom 0. So for verticals, if you can't make the bottom 0, you can't find any vertical asymptotes. Does that make sense? You got to be ready for what if happens if it doesn't exist, because that's big in pre-calc. The vertical asymptotes don't exist here then. Just don't have one. How about the horizontals? I asked Bob for horizontals. Is this a Bob? And then instantly I know the answer is y equals what? 0. So that means there's an asymptote right here at 0. So this has all been good, but I've been doing a lot of the explaining and talking, and you need to practice these. So I strongly recommend doing several of these homework problems. I circled that one, and then I think this is a good real-world question, and we do that on the test. We don't just give you problems without context. So now it's like, what does this mean? Well, if it's a percent, P is a percent, your percent can't go over 100%, right? That wouldn't make any sense. That's why that's there. And the percent can't be less than 0. You can't have a negative percent of something. That doesn't make sense. So that's why that's there. And then they're asking you to figure out, you know, a problem in the context of, oh my gosh, I have to graph it? Yeah, you can find verticals, horizontals. Just because it's a real world question doesn't mean all your rules don't work. It means they're more important than ever. All right, so you should try that one. And that's all that I have for you for today. All right. Save and close.